Hello, in this last video for chapter 14, we're going to go over a few more reactions of aldehydes and ketones, and we're going to learn a few new terms. So, there is a reaction that can occur between aldehydes and alcohols, and if we have an aldehyde, and then we react it with an alcohol, like this one here, and again, remember that our group can be any alkyl group. What we end up with is something called a hemiacetal intermediate. So what happens here is that OR group, that's going to add to the carbon in the carbonyl group, and then that hydrogen on the end is going to add to the oxygen in the carbonyl group. So we're adding an alcohol across that double bond, and what we end up with is our same aldehyde structure in the middle, but now that a hydrogen has been added to the oxygen, we have an alcohol on top, and then we also added this OR group on the bottom. And so this gives us that hemiacetal structure where we have an OH group on one side and an OR group on the other side. Now, the reason this is called a hemiacetal is we're halfway to forming what's called an acetyl molecule. So if we add some acid and some more of that alcohol that we started with, that OR group is actually going to replace the OH group. So the OH group is just going to kind of fly out of there. And the OR group from our second alcohol is going to come in and attach to the carbon. So now we have two OR groups bonded to that central carbon, and this is called the acetyl molecule. Now, many sugars are actually hemiacetals. For example, glucose, which we've talked about before. Now, the reason that we care about this reaction is it's really important in carbohydrate chemistry or sugar chemistry, and we do consume a lot of sugar, so we have to know how these things interact with each other. Now, many sugars do contain an aldehyde or a ketone on the end of the molecule, so that's why we're kind of focused on these reactions right now. But we'll learn more about sugars later on. Okay, so let's look at an actual example. So let's say that we're reacting acetaldehyde with the alcohol methanol. So again, the OR group, or in this case the OCH3 group, is going to attach to the carbon in the carbonyl of our aldehyde, and the hydrogen will attach to the oxygen at the top. So now we have that OCH3 group on the bottom, and we have an alcohol at the top, but the middle of our molecule stayed the same. So that is our hemiacetal intermediate because we're not quite there at the end with our acetyl group. We're halfway there. So now again, we're going to add some acid and more of that alcohol, methanol, and the OCH3 group is going to kick out the OH group on the top. And that will give us OCH3 on the top and on the bottom. And again, the middle stays the same. And that's our final acetyl molecule. So acetaldehyde is something that is present in our bodies, especially if you ingest alcoholic beverages. So acetaldehyde is an intermediate in the breakdown of ethanol, and it's broken down by the liver enzyme alcohol dehydrogenase. So if someone lacks alcohol dehydrogenase, that can make breaking down alcohol really difficult, and that person might turn red or feel kind of dizzy or sick if they consume alcohol. Um, Acetaldehyde is also found in coffee and in certain types of fruits, so it can be ingested that way as well. Okay, now another thing to notice up above is these double-headed arrows. So we have arrows going forward and backwards. So those are called equilibrium arrows. And you might remember these from a previous chemistry course, but it tells us that the reaction can go backwards and forwards. So we could easily manipulate the reaction and go back to the starting materials or try to go forward to the products. Okay, so let's just kind of summarize there what we learned. So we saw that the hemiacetal general formula has that OH group on the top, the OR group on the bottom, and then the middle of the aldehyde stays the same. Then once we add more alcohol, we form the acetyl molecule, which has the general formula of OR on the top and bottom. And again, the middle stays the same. Okay, now we can also see this type of reaction with ketones. And again, some sugars do have a ketone on the, well, sort of near the end of the molecule, kind of in the middle. But if we react a ketone with an alcohol, we get something really similar. So that OR group again is going to add to the carbon in the carbonyl group, and then the H will add to the oxygen at the top. So now we have an OR group on the bottom and an OH group on the top, similar to before. And the middle stays the same. So the difference here between the ketone and the aldehyde is that extra alkyl group in the middle, highlighted in yellow. So instead of a hemiacetal intermediate, we form something called a hemiketal intermediate. And similar to before, if we add acid and more alcohol, that OR group from the second alcohol is going to add to the carbon and kick out the OH group. So then we have two OR groups, one on top, one on bottom, and the middle stays the same. And this final product would be called a ketal molecule instead of an acetyl molecule. All right. So if we look at an actual example, acetone, which is found in nail polish remover and is also a really great solvent that dissolves a lot of different molecules. If this reacts with an alcohol like ethanol, again, that OR group, the OCH2CH3 group, will bond to the carbon, and the hydrogen will bond to the oxygen. So then we get that OR group on the bottom, the OH group on the top, and that is our hemiketal intermediate. And again, the middle is just staying the same, so we've got those two alkyl groups. So now if we add more alcohol, again, that will add to the carbon in the middle and kick out our alcohol group. So then we have those two OCH2CH3 groups, which we could also call ethoxy groups. So you might remember that from our previous discussions of ethers. Okay, so then that gives us our final ketal molecule. So again, notice that we're using equilibrium arrows. So we could go back and forth from products to intermediates to starting materials. So let's summarize the ketone reactions here. So remember, the hemiketal general formula has an OH group on top, an OR group on the bottom, and then the middle just stays the same with those two alkyl groups bonded to the central carbon. And then the ketal general formula, after we add more alcohol, is going to give us two OR groups, and the middle stays the same. Okay, now let's start getting into that carbohydrate chemistry that I mentioned earlier, so that sugar chemistry. So even though most sugars can be found in what's called an open chain form, where you have sort of this line of carbon atoms, and then there's an aldehyde on the top. The more stable form of this is the cyclic form. So what happens here, I'm just going to kind of draw the generic form. What happens is there is an alcohol on, let's see, one of these carbons here, and this alcohol is going to form a bond with the carbon at the top that's in the aldehyde group. So that's what's shown here, although they kind of wrapped the structure in a circle. So we've got our OH group, and that's going to interact with the aldehyde, which is shown here. And what happens is the oxygen from the alcohol end is going to be attracted to the carbon in the aldehyde group. And then the hydrogen will be attracted to the oxygen, similar to what we saw before. So remember, we said that the oxygen will be attracted to the carbon, the hydrogen will be attracted to the oxygen. Same thing is happening in this sugar example. So we end up forming an OR group on one end, which actually, let me highlight it in blue since that's what I've been using up to this point. So this is our OR group. And then our alcohol is right here. And then the rest of the molecule stayed the same. So this is our hemiacetal group. Now, if we react this with more alcohol, which is shown down below, again, just like before, that OR group is going to be attracted to the carbon in the middle, and that's going to kick out our alcohol group. So now we have an OR group there. We've got our other OR group here. It just looks a little different than before because we're forming a ring structure, and the rest of the molecule stays the same. Okay, now this is a little more complex, so don't worry if it's really confusing right now, but I just wanted to connect what we were learning before with carbohydrate chemistry, because this is really important for the biological side of things. Okay, so let's look at an actual example of a cyclic hemiacetal. So glucose, which is a sugar that we're all probably pretty familiar with, is found in both an open chain form and in its more stable cyclic form. So in the open chain form, we have an aldehyde at the top, which is just abbreviated CHO. And then we actually have that alcohol that's going to bond with the CHO group at the top. So the O, the oxygen, is going to attack that carbon at the top. The hydrogen is going to attack the oxygen. So then we end up with our, oh, let me actually highlight the part that stays the same. So this carbon here is this carbon here. And then we've got our OR group, oops, off to the side. And we've got our OH group down here. So glucose is often found in its hemiacetal form because it is more stable. And again, this is more complex, so don't worry too much about trying to remember the cyclic hemiacetal and cyclic hemiketal forms. But I just wanted to show you how it connects to sugar chemistry. Now, once we've formed acetyls and ketals, they are pretty stable. But remember earlier we saw that there were those equilibrium arrows, so we could go backwards. And the way that we would go backwards is through something called hydrolysis. So we're going to add a water molecule to our acetyl or ketal molecule and a little bit of acid to catalyze the reaction. And this will take us back to our original starting materials. So overall, let me just erase my highlighter there. Overall, hydrolysis is the cleavage of a bond by reaction with water. So we're going to break a bond by adding water. So let's say that we have our acetyl molecule here with our two OR groups. We're going to add water and a little bit of catalytic acid. So this is our catalyst. And we're going to go all the way back to an aldehyde. And we're going to form two alcohol molecules. Because remember, if we go back to our reaction, here, let's go back here. Remember, if we start with an aldehyde on the left, we're going to add one alcohol molecule to give us the hemiacetal. But the hemiacetal is really unstable, so then if we add more alcohol, it will turn into the acetyl group. So in the forward direction, we have an aldehyde reacting with two alcohol molecules. So it makes sense that if we go backwards, the acetyl molecule will turn back into an aldehyde and two alcohol molecules. Okay, and again, this occurs through hydrolysis. Now we can do the same thing with ketal molecules. So we've got those two OR groups, and then we've got the center here, which stays the same. And if we add water and some catalytic acid, we end up back with our ketone and two alcohols. So let's look at a specific example here. So here it looks like we have two alkyl groups surrounding that middle carbon. And then we have our two OR groups, or we could also call these ethoxy groups since there are two carbons in each. And then we're going to add water. Now, what's essentially happening here is one of the hydrogens from water is going to attach to the ethoxy group on top. The other one is going to attach to the ethoxy group on the bottom. And that's what's going to give us are alcohols. So we have two of them. And then the oxygen from water is actually going to, let's see, I'll use orange here. That's going to bond to carbon. But the rest of the molecule stays the same, so that central carbon with the two alkyl groups. Okay, now that's not, the full picture of what happens, but that's essentially what's happening. And it's a good way to remember the products here. So let's practice. Let's go over some of these problems that we've talked about, some of these reactions. So I'm going to give you 3 reactions, and I want you to try to figure out any intermediates or final products. Okay, so here you're going to figure out an intermediate. And then the final product. And let's see, we're going to do something similar down below. And then finally, let's do one more. Okay, so see if you can fill in those boxes. And I want you to pause the video, try it on your own first, and then when you unpause, we'll go over it together. Okay, let's start with the top problem there. So let's see, do we have an aldehyde or a ketone? An aldehyde, because we have that hydrogen on one side. And then it looks like we've got a methanol alcohol here. So I'm just going to highlight the different parts. And we know that the OCH3 or OR group is going to attach to the carbon in the carbonyl of the aldehyde. And the hydrogen is going to attach to the oxygen up above. So that's going to give us our intermediate. And what is that intermediate called? A hemiacetal intermediate. Okay, so then let's say we add more alcohol with some catalytic acid there. What would happen? The OCH3 is going to come in and kick out the OH, and we end up with our final product. And what is that molecule called? An acetyl molecule. Okay, now let's go to the second problem. This one's very similar, although this time it looks like we're starting with a ketone because we have alkyl groups on both sides. So again, same as before, that OCH3 is going to attack the carbon in the carbonyl group. The H, oops, I meant to highlight that, you know what I mean. The H is going to attack the oxygen. Okay, so we're going to end up with an intermediate here with an OH on top OCH3 on the bottom, and then we'll just fill in the rest. And what would this intermediate be called? Hemiketal. Okay, and then if we add another alcohol, that's going to come in and kick out the OH. All right, and what is that final product called? A ketal molecule. Okay, now let's look at the last problem. Here it looks like we're starting with an acetyl molecule. We've got the two OR groups, and then the middle has a hydrogen on one side. So that tells me we started with, did we start with an aldehyde or a ketone? An aldehyde. Okay, so what I'm going to do, let's see, I'm going to highlight these hydrogens, and then I'm going to highlight this meant to highlight in yellow, this oxygen here. So the hydrogens are going to bond with the oxygens on those OR groups, and then the oxygen is going to bond with the central carbon. So we'll end up with our aldehyde, and then also our two alcohol molecules. And I'll put a 2 in front. Okay, so we started with an aldehyde and two alcohol molecules. All right, so let's summarize in words all of these different reactions we've learned. So we saw that if an aldehyde reacts with an alcohol, that's going to form a hemiacetal intermediate. And then if we add some acid and more alcohol, we get the acetyl product. Plus H2O, but the acetyl product is the most important one. We can do the same thing with a ketone and an alcohol, but this time we're going to form the hemiketal intermediate. And then if we react this with acid and some more alcohol, we get the ketal product plus some water. And then we can go backwards. So let's say we start with an acetyl molecule and react that with water. We're going to add some catalytic acid, H+, and that's going to give us our original aldehyde and two of our alcohols. Same thing if we start with a ketal molecule, react it with water and some catalytic acid, we're going to get back the original ketone plus two alcohols. All right, now your textbook does have a really nice chart showing all of these different reactions we've talked about in this chapter. So in this chapter, we were covering aldehydes and ketones. And initially, we said that if we oxidize an aldehyde, we're going to end up with a carboxylic acid. But if we oxidize a ketone, there's no reaction. Then we said that we could reduce the aldehyde or ketone using hydrogen and platinum. So this would be called hydrogenation. If you have an aldehyde, you're going to form a primary alcohol. if you have a ketone, you're going to form a secondary alcohol. And then finally, in this video, we saw that if we react an aldehyde or a ketone with an alcohol, we get hemi formation. So if you have an aldehyde, you get the hemiacetyl intermediate, which eventually becomes the acetyl molecule. If you have a ketone, you get the hemiketyl intermediate, which eventually becomes the ketyl product. Okay, and that is the end of this chapter. So I will post flashcards. I'll also try to post this figure because I know these can kind of help too. And then if you do have any questions, please feel free to post in the questions and answers discussion board, or you can email me or message me on Canvas.